2.6. Solve compound inequalities. The main objective in this section is to be able to collect and interpret the answer for the compounding inequality that statement connect with and or. So solving compounding inequality with the statement and is basically we are looking for the intersections of compounded inequality, which is two inequalities. So another way of saying is we are interested in overlapping part. Okay, overlaps on the solution. So if you look at the strategy, step one, we're gonna solve each inequality individually, separately, and then we're gonna try to collect the answer by looking at where they overlaps. So when you on a test or when you're looking at doing homework problem, it's very important that what kind of compounded inequality statement the question is asking for. In this case, and so we are interested in looking for overlaps. Okay. So first we're gonna solve each inequality, which is adding 7 to both sides. That gives me 4x is less than 16, and dividing both sides by 4, which will give me x is less than 4. On the right hand side, you subtract 8 to both sides. That gives us 5x is greater than or equal to negative 5, and divide both sides by 5, which gives us x is greater than or equal to negative 1. So we solved each case already. Now we are interested in getting the answer for this compounded inequality. So this is the best way to visualize and then talk about the answer. All right. So here's a real number line, and here's 0, and this is 4. And we can see that from the first inequality, it said that x is less than 4, so it'll be open circle and go into the left directions. And then the next inequality, on the second part of the inequality, the answer is x is greater than or equal to negative 1. So here's negative 1, greater than or equal to, so therefore it is what? The closed circle, and then go into the right direction because greater than or equal to negative 1. And notice that I graph it on top of each other so that it will help me to visualize it better. Where do they overlap? So the overlapping part is basically what? Between 4 and negative 1. So that will be our answer, the overlapping part. And 4 is not inclusive, and negative 1 is inclusive, so it will be a closed circle like this. So that help us to graph our solution. And remember, this is only just your side work. Okay, this is just your side work, so you cannot use this as your solution for graphing. So here's negative 1, here is 4, and my answer has to be in between these two values. And finally, interval notation is smallest value to the largest value, so negative 1 to 4. And you can see that negative 1 is inclusive and 4 is not inclusive, so we use parentheses. And that will be our solution. Okay. Going to the next example, example 2. Again, this is a compounded inequality with the statements and. So we are looking for the overlap part, right? We are looking for overlapping part. So solving each case, that will be distributing first, which is going to be 6x plus 2 is less than or equal to 20. Subtracting 2 to both sides, 6x is less than or equal to 18. And divide both sides by 6, which will give me x is less than or equal to 3. Then distributing the next inequality by 4, so it'll be 4x minus 4 is less than 2. Adding 4 to both sides, that will give me 4x is less than 6. And divide both sides by 4, which is going to be 6 over 4. And then you need to reduce it, right? So when I reduce it by 2, that will be x is less than 3 over 2. And as in previous example, we're going to try to visualize our graph first on a side work, right? So that way it will help us to see better what is my solution is. So here's number line, here's 0, here's 3. So it said that x is less than or equal to 3, so less than or equal to inclusive, close circle, and then we're going to draw to the right hand side, because less than 3 means negative numbers. And the next one is x is less than or equal to less than 3 over 2. Here's 3 over 2, right? 3 over 2, 1.5. So that will be open circle because of less than, and it is going to this directions. Now this helps us to see better on where these two inequality, the solution of these two inequality overlap. So the overlapping part is only from negative infinity to up to 3 over 2. And we know that 3 over 2 is not inclusive, so open circle. So then my answer for the graph will be, here is the real number line, here's 0, here's 3 over 2, and open circle, and then go into the left. Interval notations is always writing from the smallest value to the largest value, so it'll be negative infinity to 3 over 2. Positive infinity, negative infinity is always parentheses. And since 3 over 2 is not inclusive, we use parentheses to indicate that also. That will be my answer. Example 3. And component inequality is n. So that basically means we are interested in looking at the overlapping part of those two inequalities, right? Overlapping. So first, I add 3 to both sides. So that will be 1/4 x is greater than or equal to 2. Multiply both sides by 4, which gives me x is equal, greater than or equal to 8. The second inequality, first we distributed negative 3, so it'll be negative 3x plus 6 is greater than or equal to 2. And then after that, solving for x, so we subtract 6 to both sides. So that will be negative 3x is greater than or equal to negative 4. Dividing both sides by negative 4, no, -3, which is this give us the inequality, switch it around. So that will be -4 over -3, which is x is less than or equal to 4 over 3. Okay. Now, let's try to graph each case and to find out our final answer, like in previous example. So here's my side work, right? So here's 0, here is 8. And the answer said that for the first part, x is greater than or equal to 8, so it'll be a closed circle going to this direction. Then the second inequality said that x is less than or equal to 4 over 3, so here's 4 over 3, and less than or equal to, so again, closed circle going to this direction. So by looking at this, you can see that there is no overlapping part at all. So what does that mean? If there is no overlapping, that means no solution. So for the graph, we basically don't need to graph anything. Interval notations, we already know that from previous sessions, this will be no solution. Okay? So that these are the variations of compounded inequality within solution. Okay. So the next step is a compounded inequality with OR statement. OR is basically talking about the union. You read it in the beginning of this session, right? And union, that is basically means what? All together. You are interested in talking about everything together. Okay. So first example, as usual, you will see the compounded inequality. There's two different inequalities that's connected by either and or or. Now we are looking at or. So we're gonna be solving like previous example, solve each case and then collect the answer. So all that means what? All together. Okay, that's what we are interested in. So first stop, subtract 1 to both sides. That becomes -4. Then you divide both sides by -2. So whenever you multiply or divide by a negative number, the inequality symbol switch it around. Don't forget that. And then that gives us the final answer, x is greater than or equal to 2. Now, moving on to the next part. Subtract 7 to both sides. That gives us 3x is less than or equal to -3. And divide both sides by 3, which gives us x is less than or equal to -1. Okay. So now, as usual, we're going to try to visualize our graph. Okay. So here's the graph. Here's 0. This is 2. And so the first inequality solution is x is greater than or equal to 2. So close circle to the right side. The second inequality is set that x is less than or equal to -1. So here's -1. And less than or equal to, so it will be a closed circle again, going to the left-hand side. But this time, we are looking for what? The compounded inequality with OR. That means the solution must be together, all together from first part of inequality and the second part of inequality. So that means our solution will be this portion and this portion all together. that would be our final solution. So you have to be careful with what kind of compounded statement we are talking about, right? Because the graph looks similar to the previous one, but the interpretation is different. So 1, my answer will be, there's -1. Here's 2. And this is a closed circle going to the right hand side, closed circle going to the left hand side. Interval notations, once you got the graph, write it from the graph. So it will be -infinity to -1. Infinity is not inclusive. -1 is inclusive, or it will be bracket union with bracket 2 to positive infinity. So that would be our final answer for this session example. Next, solving compounding inequalities. Again, or, so we are interested in all together. Solving each case, first subtract 2 to both sides. That'll give me 4. And divide both sides by -1, so the inequality symbol switch it around. So 4 divided by -1. So therefore my answer is x is greater than -4. X is greater than -4. On the second part, 6x is greater than, after you add 8 to both sides, that become 18. And divide both sides by 6, which will give me x is greater than or equal to 3. So now, like before, graph each part to visualize it. And gradually you improve and then don't need to visualize. Okay? To a point that you don't need to visualize. So x is greater than -4, so it's not inclusive, so we use open circle greater than -4. That means 3, 2, 1, so on and so forth. And the second inequality, the solution is x is greater than or equal to 3. So here's 3 is inclusive, closed circle, greater than or equal to, so going to that direction. In this case, we are looking for the component solutions of component inequality with or. That means our solution must be all together. Right? So that means if I combine this red and then blue graph together, that will be starting from here and everything go down. So my answer will be, here is my graph, -4, open circle, go into this direction. And interval notations, right? Interval notations will be the smallest value, which is -4, to infinity, to infinity, okay? To infinity. Now the question is, -4 is not inclusive or not? In this case, it's not inclusive, so it will be parentheses. Okay. Next example. Again, component inequality or, so that means all together. So solving each case, 3x, adding 2 to both sides, that'll become 3x is less than 15. And divide both sides by 3, so therefore x is less than 5. On second inequality, subtract 5 to both sides, that gives us x is greater than 2. So visualizing again, here's 0, here's 2, here's 5. So the first inequality tells us x is less than 5, So open circle, go into left directions. The second inequality tells us x is greater than 2. So here's open circle because greater than, and then go into the right hand side because greater than 2, right? It'll be 3, 4, 5, so on. And the compounded inequality, the solution of compounded inequality is all together because we have a statement or. So that means the red and the blue graph combined together, which is, this is what we get, everything together. So this is infinitely many solution case because you see that it filled up the whole real number line. So here's 0. This will be my graph. And how do we write infinitely many solutions? From the previous, we know that it will be negative infinity to positive infinity. Lastly, we are interested in looking at the inequality that has a double inequality symbol. Okay, and the equivalent statement of this double inequality symbols are using the compounded inequality with and statement, but um, we will not run into those kind of case a lot, so we can just solve it as it is. So in this case, since we have double inequalities, when you add or subtract, multiply, divide, you're going to have to do to all three parts of the inequality. So meanings, for this one, if I want to solve for variable x, meaning isolating x on the middle, then I need to add 1, and I need to add 1 to the right hand side and also add 1 to the left hand part. All three parts of the inequality, you have to add it up. So um, now that gives us this answer, which is negative 4 is less than or equal to 4x less than 8. Less than 8. And finally, we divide all three parts by 4. So it will be negative 4 divided by 4. 4x divided by 4. And then 8 divided by 4 also. So this gives us negative 1 is less than or equal to x less than 2. And this kind of inequality is much easier to write this answer because it already tells you the variable is trapped between negative 1 and 2. So my graph will be, here's a real number line, here's negative 1, here's 0, here's 2, negative 1 less than or equal to, so it will be closed circle, and 2, right, it's open circle, not inclusive. So our answer will be between these two. Right? And interval notation is smallest value to the largest value, so therefore it will be from negative 1 to 2. And negative 1 is inclusive, so it will be brackets, and 2 is not inclusive, so parentheses. That will be the end of the answer. So the next example, which is the last one, is the same thing as the previous one. So first, I'm going to add all three parts to by 5. Now this time I will skip the step, right? So negative 3 plus 5 will become 2 less than 2x less than 1 plus 5 will be 6. Now we divide both sides by all three parts by 2, which is 2 divided by 2 is 1. And 2x divided by 2 will be x, right, itself. And then lastly will be what? 6 divided by 2, which will be 3. So if you don't write down, if you skip the step, it will be very fast. Finally, my answer will be the subtract between these two numbers, 1 and 3. And 1 is not inclusive because of the less than symbol. 3 is also not inclusive because of less than symbol. So the value x is between these two numbers. And finally, my interval notations will be between 1 and 3. So smallest value is 1 and the largest value is 3. Both of the endpoints are not inclusive, so parentheses. And that will be the end of this section.